let's look at the pressure and dynamic equilibrium. This is one of the three main factors affecting dynamic equilibrium according to Le Chatelier's principle. So we've already done temperature and pressure. Sorry, and concentration. We're looking at pressure now. So if you change the pressure, you're definitely going to stress the dynamic equilibrium, and it won't be in the middle of your reversible reaction. It will shift either to the right or to the left. Now, depending on how the pressure increases or decreases, our dynamic equilibrium is going to shift. So if you increase the temperature, the equilibrium will shift in order to decrease the pressure, and it will shift in the direction of the fewest molecule. So your equilibrium is going to shift to the direction of the fewest molecules in order to decrease that pressure. If you decrease the pressure, the stress equilibrium will try to increase that pressure, so it will shift in order to increase that pressure, and it will do that by shifting to the direction of the most molecules. Let's look at an example. Here we are. We have the dimerization of nitrogen. We've seen that with temperature as well, into dinitrogen tetroxide. Okay, so here's our equilibrium in the middle, dynamic equilibrium, a symbol for reversible reaction here, you can see that. If we increase the temperature, we're going to stress our dynamic equilibrium, and it's going to move to the fewer molecules, the fewer moles in this reaction. So the fewer moles are the numbers that are in front of our compounds here. So we have 2 nitrogen dioxides and we have 1 molecule of dinitrogen tetroxide. So our dynamic equilibrium is going to shift in order to decrease that pressure. So if you increase that pressure, the dynamic equilibrium will want to do the opposite in order to balance. So if you increase the pressure, the equilibrium is going to shift in order to decrease it, okay, so it can balance out. Now, it will do that by moving to the side with the few molecules, the few moles. It's going to move to this side, okay? Now, if the fewer moles were on this side, it would have moved on that side. So in this case, you have to see which side has got the fewer moles, the fewer molecules. If you increase the temperature, your stress equilibrium is going to shift to the side with the few molecules. Now, if you do the opposite, decrease the temperature, what do you think will happen? You can pause the video and think. It must be opposite to increasing the pressure. So, if you decrease the pressure, you will have an equilibrium that's stressed and out of balance, and therefore it will move to the side with more molecules. It's going to move here to the left in this case. So increase the pressure, moving to the few molecules. Decrease the pressure, it's going to move to the high molecules. Okay, and you can see at the bottom, if you increased, you're going to have a movement to the fewer molecules, and therefore more of them will be produced in the process. And if you decrease the pressure, the dynamic equilibrium is going to shift to the side with more molecules, and more of these molecules will be produced as a result. So hopefully that makes sense. As a practice, you can use this slide to bring together what you've learned from the section of temperature, concentration, and pressure. Okay, so remember that the equilibrium in a system, when it's stressed, is trying to balance that stress. Okay. Hopefully you remember what the symbols are. Okay, energy changes, and why is a negative number here. So normally you need to remember the negative numbers are exothermic reactions, will give negative numbers. Okay, kilojoules per mole. So in this case we have nitrogen gas reacting with 3 hydrogen, so in this case 3 double hydrogens, so 6 hydrogen atoms, or 3 hydrogen molecules of gas, of hydrogen, and they form ammonia, 2 molecules of ammonia gas. So you can see, if you increase the temperature, what will happen? If you increase the temperature, is your equilibrium going to move to the left or to the right? So obviously if you increase the temperature, you need to remember to the left or to the right. You can pause, you can check the video to find out. And then if you decrease the temperature, what will happen? So here's only 3 examples. 2 examples of pressure and temperature and a catalyst. You can do more than that if you want. You can write down what happens if you increase or decrease the temperature, increase or decrease the pressure, increase or decrease concentration, and then also adding a catalyst. Remember, as said in previous videos, catalysts have no effect on the position of the equilibrium. It's just they provide a constant rate of the reaction, either forwards or backwards. Okay, the presence of catalyst is just going to speed up the reaction. It won't change the position of the equilibrium. Okay, and you can pause the video to work on this one and then look at your answers with compare your answers with the table.